All right, so let's go over a few really important formulas. One formula that we have to go over is calculation of your empirical formula, obviously. And then we have to go ahead and we have to discuss about our percentage purity, percentage yield, all of that, right? So let's go ahead and go over the formula for percentage yield. I'm going to share the formula with you guys, and then let's take a look at a few practice questions. What is percentage yield? Percentage yield is basically, simply put, sometimes, when you do any experiment, you do any chemical reaction, you might notice something very interesting. You might notice that the amount of product you're getting is lesser than what you had calculated, right? So when we were performing the chemical reaction, performing the experiment, we calculated that this is the amount of volume of product we should have gotten. But instead, we got a different value, lesser value. Okay. So this is basically referred to as percentage yield. Okay. So the formula of percentage yield is actual yield divided by theoretical yield multiplied by 100. Actual yield is the yield that we actually calculated in the experiment. Okay. Theoretical yield is the yield that we had calculated. So actual yield is the yield that we had measured. That this is the amount of product that we have gotten after the experiment has been completed. This is the amount of product we ultimately got. Theoretical yield is a calculated yield that before we did the experiment, when we calculated, this is the amount of product we thought we will get. And actual yield is the product we actually ended up with. Let's go ahead and take an example. For example, okay. So your question says we are heating 12.4 grams of copper carbonate uh, in a crucible produce 7 grams of copper oxide. What was the percentage yield? Now, for us to calculate, so you can see that over here, the 7 grams that the examiners have given, okay, the 7 grams. The 7 grams is the actual yield. This is the yield of copper oxide that we actually got. When we performed the experiment, this is the yield of copper oxide we actually got. We need to calculate before we can calculate the percentage yield, we need the theoretical yield. Now, you guys should remember the equation of thermal decomposition of copper carbonate. I went over all the thermal decomposition equations with you. Copper carbonate will decompose to give you copper oxide and carbon dioxide. Okay. Now, you have to figure out the theoretical yield. So you basically have to figure out, this is the actual yield. We have the mass. So now again, in the theoretical yield, you need to find the mass. Mass of what? Mass of copper oxide. You have 12.4 grams of copper carbonate. Please go ahead, use your mole calculations, do the mole calculations like we discussed in the last class, and find out the mass of copper oxide. Please calculate just using the mole calculations, just like we discussed in the last class. You have the mass of copper carbonate. Using the steps that we discussed in the last class, please find the mass of copper oxide. For the MR that you guys want of the compounds, use the periodic table. Okay, use the periodic table. Use the periodic table to find out the MR of the compounds, right? Use the steps I taught you in the last class and calculate the mass of copper oxide that will be formed theoretically using mole calculations. What is the mass of copper oxide that will be formed? If you need to see the periodic table or anything, you guys can ask me, or even you guys can Google it up, whatever you prefer. Did you guys get the answer yet? What will be the mass of copper oxide that we will get? Hajra, Shreya, anybody get the answer yet?
I got it as 7.98.
Okay. Shreya, what are you getting? Or do you need a bit more time?
Yeah.
Okay, all right. Okay, then let's wait for Shreya. Shreya, if you need any help, let me know.
Yeah, I need help.
All right, no problem. I'll go over it with you. So, step number one is always find the moles of known. Moles of known. So, what is known? Copper carbonate is known. Okay. So, you'll find the moles of copper carbonate. So, how are you going to find it? Look, we have the mass. If the mass is given to me, Shreya, what formula can I use to find the moles? Which formula should I choose over here?
Mole is equal to mass over MR.
Good, correct. So the mass is 12.4. Can you open the periodic table and do the MR with me? Can you check the mass of copper from the periodic table? What's the mass of copper? Hajra, what's the mass of copper from the periodic table?
63.5.
Right, correct. 63. And then we have carbon. Carbon, if you look in the periodic table, is 12. And oxygen, if you look in the periodic table, it is 16. And there are 3 oxygens, so we will multiply by 3. Okay. So we will, this is how you're going to do step number 1, mass of unknown. So you have the mass, you divide it by the MR. MR, you can calculate using the periodic table. Copper plus carbon plus oxygen multiplied by 3. So you will get the moles. Hajra, what do we get as our moles?
I got it as 123, I think.
Moles? That's a very huge value for moles.
I actually didn't write it down. I just did it in the calculator.
Yeah, maybe. 63 plus 12 plus 16 into 3 gives us 123. 12.4 divided by 123 is 0.1. You get 0.1 moles. Okay. So Shreya, once you found the moles of known, now you'll find the moles of unknown. How do we find the moles of unknown? We always find the moles of unknown by using mole ratio. Okay. So mole ratio is always like this, that moles of copper carbonate divided by moles of copper oxide. Okay. So you divide the two moles. So moles of copper carbonate are 0.1. The moles of copper oxide are unknown. We don't know what the moles of copper oxide are because copper oxide is unknown. Is equal to. After you write down the equal to, Shreya, you write down the balancing. So how many copper carbonate? 1. How many copper oxide? 1. So you cross multiply and you get the value of X. So moles of copper oxide come out as 0.1. So copper oxide will have the same number of moles, 0.1. Step number 3 is calculate value. Whatever the examiners have asked you, find the mass, find the volume, find the concentration, whatever the examiners have asked you, you find that. Okay. So that is going to be, we have to find the mass and the moles are given to us. So use the same formula again. Moles is equals to mass over MR. The mass we have to calculate. The MR is going to be copper is 8 and oxygen is 16. This is equals to, the moles are 0.1. So you solve for X. So 0.1 multiplied by 63 plus 16. So your answer will come out as 7.9 something, which you guys can round off to 8 grams. So now we can see that the mass of your copper oxide is going to be 8 grams. Right, Shreya? Making sense now how we're doing the calculations?
Yeah.
You can always use these steps, okay? Moles of known, moles of unknown, and then calculate the value, which is volume, which is mass, which is concentration, whatever the examiners are saying, okay? So this is how we do any calculations. Now, we have to calculate the percentage yield. For the percentage yield, you can use the formula I taught you guys, okay? Actual yield, the formula is actual yield divided by theoretical yield multiplied by 100. So see, the actual yield that we had gotten was 7 grams, right? 7 grams of what we gotten. So actual yield is 7. Theoretical yield, the yield that we calculated is 8 grams. But we didn't get 8 grams when we did the experiment. We got 7 grams and multiplied by 100. So what do we get as our percentage yield, Hajra? Can you calculate?
Yeah. 87.5%.
87.5%, correct. Good. That's how you guys are going to calculate your percentage yield. Now, another thing that you guys will have to calculate along with percentage yield is you guys can be asked to calculate percentage by mass as well. And then, of course, you can have questions on atom economy, and you can be asked about your mole, your titration calculation. So, what do we mean by percentage by mass? Okay. So, percentage by mass, I will explain to you guys much easier if I actually share a question with you guys. So, let me share the question 1 second. All right. So, how will you attempt questions like this? First thing is first, you guys should be able to read the compounds and figure out what the formula should be, right? So, we have ammonium nitrate. Ammonium nitrate is NH4 NO3. Okay. So, what are you guys going to do? You are going to do to calculate the percentage by mass, we are going to do mass of nitrogen divided by molecular mass multiplied by 100. Actually, let me correct it. When I say mass of nitrogen, I mean atomic mass, not like in mole calculations, we usually have it in, like proper values. Over here, we're using atomic mass from the periodic table. Okay, this is from the periodic table. So if you guys open the periodic table, you will see that the mass of nitrogen is 14. And how many nitrogen do we have in ammonium nitrate? We have 2 nitrogen. So we will do 14 multiplied by 2. We divided by the molecular mass. So molecular mass will be, we have 2 nitrogen. So 14 multiplied by 2 plus. Again, if you look in the periodic table, you will see hydrogen is 1. So 1 multiplied by 4 plus. Look in the periodic table and oxygen is 16. 16 multiplied by 3. And then you multiply by 100. So quite simple. Simply take the mass of whatever element the examiners have asked you. Okay, they've asked you nitrogen, they've asked you oxygen, they've asked you hydrogen, whatever. You take the atomic mass, not you like the atomic mass, divide it by the molecular mass and calculate the percentage. So what, Haja, can you tell me what percentage you will get if percentage by mass?
Yeah, I'll just do it in the calculator. It says 35%.
Yes, 35% is correct. Okay. After this, let's take a look at another important formula, and that's your atom economy. Okay. So, what is your atom economy? Atom economy is basically calculated in such a way. So, atom economy is simply a way of measuring the desired useful products that are formed from the reactants. What does that mean? That basically means this, that we are performing a chemical reaction where we want a very specific product. Okay. So you and I are performing a chemical reaction because we want to, let's say, okay. So our reaction is this, that we have methane. We take our methane, react with oxygen. This is a combustion reaction. The desired products is basically water. So we are performing a combustion reaction to get water. We will get water, and of course, we will get carbon dioxide. Okay. So atom economy is basically percentage of desired products compared to the total reactants. So quite simply put, you know how in physics we study efficiency, which is useful energy output divided by total energy input. Same thing. So I am inputting, my input is methane and oxygen. From that methane and oxygen, how much of the output is useful? How much of the output is water? That is basically atom economy. Okay. So it is the same as efficiency in physics. So the input is methane and oxygen. Let's balance the equation first. Yeah. Input is methane and oxygen. The output is we're getting both carbon dioxide and water. But carbon dioxide is not our desired product. Water is. So carbon dioxide is basically a byproduct, the product that we have, but we didn't really want it. So how do we calculate? We will first, you guys will find total mass of the reactant. The way you find the total mass of the reactant is you guys can simply go ahead and calculate the molecular mass using the periodic table. So we have CH4, carbon is 12, and we have hydrogen is 1, and therefore hydrogen. So we will get 16. Then we have oxygen. Oxygen, there are total of 4 oxygen. Can you guys see over here? Total of 4 oxygen. So we one oxygen is 16, right? So we will multiply by 4. That will give us 64. Then you will find the total mass of the desired product. The total mass of the desired product is, water is our desired product. So we have to find the mass of H2O. There are 2 hydrogens, so 1 multiplied by 2 plus, and there is 1 oxygen, so 16. Okay. Now we have to multiply this by 2. Why? Because we're getting 2 water molecules. So you will get a total of 36. And finally use the formula. Desired product divided by mass of reactant multiplied by 100. So our atom economy comes out as 36 divided by 64 plus 16 multiplied by 100. So atom economy comes out as 45%. Okay. Now I want to add one thing. Over here, do you guys see how I am multiplying by the number of molecules? So there were 2 molecules of water, so I multiplied by 2. Oxygen I multiplied by 4 because we have total of 4 oxygen. This is only in atom economy. Okay. Only in atom economy will you multiply it by the number of the balancing. Only in atom economy will you multiply it with the a number of molecules. Why? Because in atom economy, we're trying to find the total mass. When you are calculating just the molecular mass, you are doing mole calculations and you're calculating just the molecular mass, then please do not multiply it by the balancing. If I asked you what is the MR of oxygen, you guys will do 16 multiplied by 2, not multiply by 4. Why? Because MR is only with the molecule. In the molecule, there are 2 atoms of oxygen. That's it. Molecular mass. The reason we are multiplying it by I need to do. Just give me 1 second, guys. Right. So, okay, like I was saying that the math over here, right? So when you guys are calculating just the molecular mass, you don't multiply by the mole ratio. So if I said find the molecular mass of oxygen, you would just do 16 multiplied by 2. Okay. This number is not important. The only time you need to multiply it by this number is when we're calculating the atom economy. Okay. Otherwise, if they say find the molecular mass of water, you will simply calculate the molecular mass of water. So 1 multiplied by 2 plus 16. You will not multiply it by 2. Why? Because molecular mass is just the mass of that one molecule. Okay, we don't need to multiply it by the total number of molecules. So this is how you guys are going to find your atom economy. Now, along with atom economy, one really important portion of all mole calculations is your calculations related to your titrations. Okay, so in the titration calculations, once again, the steps are going to be similar to what I've taught you guys previously. Okay, uh, I'm going to go over some calculations with you, and then you guys will attempt a question. So our question is, let's say, a solution of hydrochloric acid is titrated against a sodium hydroxide solution. So 20 centimeter cube of acid neutralizes 25 centimeter cube of 0.1 mole per dm cube sodium hydroxide solution. What is the concentration of hydrochloric acid? So how are we going to go? Let's start with moles of known. Shreya, what is known over here? Is the acid known or is the alkali known?
The acid.
Sorry, Shreya, say it again.
The acid is known.
Look, the question is, what is the concentration of acid? So do you think the acid can be known? Because the question is, what is the concentration of the acid? So the question is about the acid. So what is known? Known is the alkali, right?
Okay.
Known as the alkali. The HCl is unknown because the question is about the HCl. They're saying what is the concentration of HCl. So we have to find HCl. Okay. So moles of known. So over here we have to deal with sodium hydroxide. So we have to find the moles of sodium hydroxide. Now, Shreya, look at the information that is given to us about sodium hydroxide and choose a formula. Choose a formula that we can use over here. This is the information that we have about sodium hydroxide. Look at what we are given and choose the correct formula or an appropriate formula that will allow us to calculate the moles.
Is it moles is equal to concentration times volume?
Yes, good job. Correct. So moles is equals to concentration time volume. That's what you're going to use. So moles is equals to concentration times volume. So the concentration is 0.1. The volume is 25. Do I need to do something, Shreya, before I do the final calculation? Is there anything else that I need to do? Is there any other step that I have to add?
Do you need to convert dm cube to some? No.
Convert the centimeter cube. Okay, you're right. One of the things should be converted. Okay, So convert your centimeter cube into dm cube. Okay. Convert the volume. If you convert the concentration, it's longer process. So you will divide by 1,000. Okay. To convert centimeter cube into dm cube, you simply divide it by 1,000. Okay. So now go ahead and can you please calculate for me, Shreya, what would be the moles over here?
Zero point zero two five.
Yes, 0.025, 0.0025, right? Oh, sorry, 0.0, yeah, that's fine. 1 second. 0.0025, that's what I'm getting. Are you getting the same?
Yeah.
Yeah, okay, perfect. Good job. Now you have the moles of known. Now we find the moles of unknown. To find the moles of unknown, Shreya, we will need the chemical equation. So the chemical equation, I will tell it to you guys, even though I think you guys can tell me the equation yourself as well. In fact, you know what? Shreya, go ahead. Can you tell me what the chemical equation will be? It's just sodium hydroxide and HCl. What do you think? If you want to take a few minutes to figure it out, you can. But what do you think should be the chemical equation? Or between reaction between HCl and sodium hydroxide?
It's HCl plus NaOH.
Yes.
NaCl plus
किसका लैपटॉप होता है खुला है वो खुला है वो छोटू के हाथ लगा लगा आई नो बट हाथ से ना लग जाए आगे पीछे छोटू भाग रहे हैं तो इसको सुधार दो थोड़ा
Right. So we will have HCl and sodium hydroxide, and we will have NaCl and water, right? Acid-base reaction will give you salt and water. So now what are we going to do? We're going to move on to moles of known. Let's go on to moles of unknown now. Okay. Now, how do we find the moles of unknown, Shreya? We always use mole ratio. How do we use mole ratio? Moles of sodium, moles of unknown moles of known divided by unknown. You just have to divide the two moles. You can write whatever you want in the denominator and numerator, doesn't matter. So moles of sodium hydroxide divided by moles of HCl. So for example, sodium hydroxide, the moles are 0.0025. For HCl, it's X. We don't know the moles of X. They're unknown. Shreya, can you tell me the balancing? What is the balancing over here for all of them? The equation is balanced. You just have to read the equation and tell me what I should write down over here for the ratio.
Is it a 1-to-1 ratio?
Yes, it's a 1-to-1 ratio. So what will be the value of X? What are the moles of HCl?
It will be the same 0.0.
Yes, correct. Okay. Now that we have the moles of the known. So first we found the, sorry, unknown. First we found the moles of the known. Then we found the moles of the unknown. So known was sodium hydroxide. Unknown is HCl. Now final thing is calculate value. What do we have to calculate? The question is about concentration. So we have to calculate the concentration. Shreya, what formula is there for concentration?
Moles is equal to concentration times volume.
Yes. So the concentration we have to calculate, it is unknown because the examiners have asked you to calculate what is the concentration. The moles we just calculated 0.0025. The volume, let's go back to the question. The volume is 20 centimeter cube. So we multiplied by 20. Shreya, do I need to do anything before I do the final calculations? Do I need to do anything before I do the calculations? Is there any important step that we have to do?
Converting.
Yes, converting centimeter cube into TM cube. So just divide by 1000. So can you please calculate what the final concentration is going to be? Your concentration is going to come out as 0.0025 divided by 20 divided by 1000. So your concentration is going to come out as 0.125 mole per dm cube. All right, so this is how you're going to do the calculations. We started with calculating the known, that was sodium hydroxide. Unknown, that was HCl. And then finally calculate the value. So whatever they ask you in the question, concentration, volume, mass, whatever, you calculate that. Okay. So this is how you are going to do your titration calculations. Right? Making sense? I hope it's clear to everyone.
Yeah.
Okay, perfect. Okay, guys, we'll go ahead and stop it over here for today. Now, okay, we have done now the theory of everything related to moles. So now in our next class, we will take a look at a few questions on it. Okay.